everybody, Mrs. Bowen here, and we're going to take a look at Learning Target 8.1. I can solve quadratic equations by factoring to find the zeros or the roots. So first, we're going to have to make sure that our equation is in a certain form. So step one, we need to get our equation in what's called standard form. So I'll say get equation in standard form. And a reminder for you that standard form is going from highest degree down to lowest degree. And here it's ax squared plus bx plus c. And we have to make sure that it's equal to 0. So here's standard form, ax squared plus bx plus c equals 0. Or we have our x squared term, then our x term, then our constant term, and it's always equal to 0. In step 2, we're going to use a whole bunch of the factoring methods that we learned in Unit 7. So we're going to use, let's see, first the GCF. If there's a GCF you can factor out. We'll use X method, and we'll use grouping to get our factors. So we'll use greatest common factor, X method, and then factor by grouping in order to get our factors. And then once you have your factors, in step 3, the new piece is that we're going to set each factor equal to 0. Set each of our factors equal to 0, and we'll solve. So we'll be solving for X equals will be your answer today. Let's see what this looks like. So our directions tell us solve each equation by factoring. Notice these are equations, meaning there are equal signs. It's not just an expression. In example 1, we definitely have an equation. And we need to make sure that our equation is in standard form. That's step 1. And here I can see I've got p squared, p constant, and it's equal to 0. I can see that my a is 3, my b is 19, my c is 6. So I have it in that form. The next thing I can do is use the factoring methods that I used in order to get the factors. So can I pull out a GCF of 3, 19, and 6? No, I cannot. So now I can move on to X method. So what I like to do for X method is draw a big X. And I need to do A times C in the top. So 3 times 6 is 18. So I'm going to be looking for two numbers that multiply to 18. In the bottom, you put your B. So I'm looking for two numbers that multiply to 18 and add to 19. Those numbers would be 18 and 1. 18 times 1 multiplies to 18, and 18 plus 1 adds to 19. Again, we spent a lot of time on this in Learning Target 7.5. So far everything is review. This means I can now split my middle term, my X term here where I have 19p. I can split it into 18p plus 1p. So I'll rewrite it. I have 3p squared plus 18p plus 1p plus 6. I'm going to remember to write the equal 0. That's a new part. It is an equation, so you cannot just drop your equal sign. If you switch the order here, instead of writing 18p plus 1p, if you instead put 1p plus 18p, that's totally fine. Now I have 4 terms, so I can split it up to do factor by grouping. And so I can look at my first half. First half, what's my GCF? I could pull out a 3p. 3p times what gives me 3p squared. 3p times p gives me 3p squared. 3p times 6 will give me 18p. Then I can look at my second half. In my second half, there's not necessarily a GCF you can pull out. You can always pull out a 1. And then I'll have p plus 6 in parentheses, still equal to 0. Worked out perfectly because I do have my common polynomial factor. So I'll have p plus 6 as one factor. My leftovers are the other factor, so 3p and a positive 1, and it's still equal to 0. So far, all of this is review. Identifying the parts of our standard form, the A, the B, the C, doing X method. Now we have 4 terms because we did X method. We did factor by grouping for first half and second half. We got our 2 factors. It's equal to 0 here. The last step, step 3, is the only new piece for this learning target. So far, all of this is review. We've covered it in other guided notes. Our last step, step 3, says we're going to set each of these factors equal to 0 and solve. So I can take this factor, p plus 6, and I can set it equal to 0. So I'll have p plus 6 equals 0. And I can also take my second factor, 3p plus 1, and set that equal to 0. So that's my last step. I now have 2 different equations that I need to solve for p. So my first equation here, I'm trying to solve it. If I'm trying to get p by itself, I would subtract 6 to the other side, and I'll get that. One of my solutions is p equals negative 6. And then for my other one, trying to get p by itself, I need to remember inverse operations, which we've worked on quite a bit. So the first thing I would need to do is subtract 1 from both sides, and I'd be left with 3p equals negative 1. Now I'm still trying to get p by itself. This is 3 times p. So to undo that, I would divide by 3, and I would get final answer, p equals negative 1/3. That's perfectly fine. We can leave it as a fraction, no big deal there. So on example 1, we've solved it. We had an equation, and we have 2 solutions. One solution is negative 6. Our other solution is negative 3. So this means you could check your solutions by plugging in. For example, we could test negative 6. We could plug it in for p everywhere we see p, and when we plug that in, we better get 0. Same thing with negative 1/3. We could use our calculator, plug in negative 1/3 for both of our p's here. Be careful, either let your calculator simplify it or use order of operations, and it should spit out 0. All right, let's look at another example, example 2. So on example 2, at first it looks like it might be in my standard form, m squared, m constant, but it's not equal to 2. So that means I have one extra step I need to do first. I have to get this to be equal to 0. So I need to move this 2 to the other side, and I can do that by subtracting 2. So then I'll get m squared plus 7m. 12 minus 2 gives us 10, and now it's equal to 0. So the only thing that's different about example 2 is I might need to move something over to the other side in order to get it to be equal to 0. So now it's equal to 0. It's in my standard form. We can go ahead and we can set up our X method. We can identify our A, our B, and our C. So for our X method, A times C, we'd be doing 1 times 10. So we need to find 2 numbers that multiply to 10. And then our B, 2 numbers that are going to add to our B, which is 7. So I need to think of multiples of 10. I know 5 times 2 multiplies to 10. And perfect, 5 plus 2 will add to 7. So this means now I will split my middle term, 7m, I'll split it into 5m plus 2m. If you wrote this the other way around, and if you instead do 2m plus 5m, that's totally fine. So here I'll have m squared plus 5m plus 2m plus 10 equal to 0. Can split it up into first half and second half in order to factor by grouping. So in my first half, my GCF, I could pull out an m. Now I need to think of it as backwards distribution. M times m gives me m squared. M times 5 gives me 5m. Now I can look at my second half. My GCF here would be a positive 2. 2 times m gives me 2m. 2 times 5 gives me 10. Still equal to 0. So now I can see that I do have a common polynomial factor. So one of my factors is m plus 5. My other factor is my leftovers. I have an m plus 2. It's equal to 0. And so this piece is review. The new part in step 3, I need to set each of these factors equal to 0 and solve. So I'll do m plus 5 equal to 0, and I'll also do m plus 2 equal to 0. So I'm setting each of my factors equal to 0 separately. So here, if I'm trying to get m by itself, I would need to subtract 5 on both sides. One of my solutions is m equals negative 5. And on the other side, if I'm trying to get m by itself, I would subtract 2 from both sides. And my other solution is m equals negative 2. At this time, you have 2 u-tries. Go ahead and pause the video. All right, here you can check the u-tries. On both of these, there was not a GCF we could pull out right away for step 1. So right away, we were starting with our X method. So you could get 4 terms and then factor by grouping. Then once you know your 2 factors, you're setting each factor equal to 0. So on the first one, my solutions to solve the equation are 6 and 1/8. And on the second u-try, I got negative 4 and 2. We can now jump to the back side. Let's do a couple more examples. So example 3, let's see, that is definitely not in standard form, so I need to get it in standard form. I do have a k squared term, I do have a constant term, and I do have a k term, but I need to get them all on the same side. So the way I could do that is by moving the positive 10k over to the other side. The way I can move a positive 10k is by subtracting 10k. So I'll do minus 10k on each side. And then I'll get k squared minus 10k plus 24. And now it's equal to 0. Notice I put the negative 10k in the middle because I'm wanting this to be in standard form. So I have ax squared plus bx plus c. So now I can go ahead, set up my x to factor by grouping. So a times c is 24. I'm looking for 2 numbers that multiply to 24, add to negative 10. Let's see, I know 12 and 2, 12 times 2 gives me 24, but 12 plus 2 doesn't add to negative 10. Even if I were to make them both negative, it's still not going to add to negative 10. Let's see, 6 and 4. 6 times 4 gives me 24. If I make them both negative, negative 6 times negative 4 multiplies to negative 24, and negative 6 minus 4 adds to negative 10. So perfect, I can split up my middle term, negative 10k, into negative 6k and negative 4k. So I'll go ahead and do that over here. I'll have k squared minus 6k minus 4k plus 24, don't forget it's still equal to 0. I can split it up to factor by grouping. In my first half, my GCF would be k. K times k gives me k squared. K times negative 6 gives me negative 6k. In my second half, right away I notice my third term is negative, so no matter what, when third term is negative, you have to pull out that negative. Here my GCF would be negative 4. Negative 4 times k gives me negative 4k. Negative 4 times negative 6 gives me negative 24. It's still equal to 0. I can see I have a common polynomial factor, k minus 6. My leftovers would be the other factor, so k minus 4. Now I know my 2 factors, I can set them each equal to 0. So I'll have k minus 6 equal to 0, and I'll also have k minus 4 set equal to 0. So to solve this, I would add 6 to both sides. So one of my solutions is 6. Here I would add 4 to both sides. My other solution is positive 4. Very last example. Let's see, example 4 is in standard form. Right away, I'm noticing all these numbers are even. So on this one, I can factor out a GCF. I'll actually make a note. On this one, I'm gonna say factor out the GCF first. If you can do that, that's always your step 1, don't forget. So I can pull out a 2. 2 times n squared gives me 2n squared. 2 times negative 4n gives me negative 8n. And 2 times negative 12 gives me negative 24. So all I did was pull out a GCF of 2 because 2 goes into each term. Now that I pulled out the GCF, now let's do our x method. So keep in mind this 2, I'm just going to continue bringing it down throughout the whole problem. But here would be my A, my B, and my C. So A times C gives me negative 12. I'm looking for 2 numbers that multiply to negative 12. They're going to add to negative 4. Let's see. I know 6 and 2 can multiply to 12. And there's a way I can manipulate 6 and 2 to add to 4. I just need to figure out which one is negative. And I do that by determining how they can add to negative 4. So if I have negative 6 plus 2, it adds to negative 4, and negative 6 times 2 multiplies to negative 12. So this means I'll split up my middle term. Instead of writing negative 4n, I'll split it up into negative 6n and positive 2n. So here I've got n squared minus 6n plus 2n minus 12, and it's still equal to 0. Now I have 4 terms, so I can factor by grouping. Notice I'm going to continue bringing down that 2. It's along for the ride. So in my first half, let's see, so I'm looking here, what's my GCF of n squared minus 6n? Let's see, I could pull out just an n. n times n gives me n squared. N times negative 6 gives me 6n. In my second half, my GCF there will be 2. 2 times n gives me 2n. 2 times negative 6 gives me negative 12. Perfect, I have a common polynomial factor. So n minus 6 is one factor. My leftovers, n plus 2 is another factor. And I should still bring down this 2. When I go to set factors equal to 0, we pulled out the GCF of 2. However, this would be a completely factored, but however, we don't need to set 2 equal to 0. That doesn't make sense. 2 does not equal 0. We're just going to set each of these factors equal to 0. We'll do n minus 6 equal to 0, and we'll do n plus 2 set equal to 0. So here I would add 6 to both sides. So one of my solutions is 6. And then here I would subtract 2 from both sides. And my other solution is negative 2. So example 4 is a good one. It covered everything. First factoring out a GCF, then doing X method, factor by grouping, and then set each of your factors inside parentheses equal to 0. Alrighty, last 2 U-tries. Go ahead and pause the video. All right, here's the first U-try. I first had to add 14v over to the other side to get it in standard form. Then once I had it in standard form and it was equal to 0, I could do my X method, factor by grouping, and then set each factor equal to 0 in order to get the solutions that v is negative 8 and negative 6. And then for the last U-try, on this one, I did pull out a GCF of 6 right away because 6 goes into every term. So I first pulled out a GCF of 6. This helped me because now I had easy numbers in order to do X method, factor by grouping, and then set each factor equal to 0 and solve. And I got that x equals 5 and x equals 1.